let us share another problem. That is, the top view of a 75 mm line CD measures 50 mm. C is 50 mm in front of VP and 15 mm above horizontal plane, and D is 15 mm in front of vertical plane and is above horizontal plane. Draw the front view of CD and find its inclination. So here we have seen three types of problems that are there. So one, first of all, angle of inclination is given, and we have to find out the final front view and final top view. Okay, then next, position of points are given, and we have gone and we have to find out the inclination with the horizontal plane and vertical plane is given, and final front view and final top view are find out. And this is a third type of a problem for line inclined to both the planes, where the 75 mm line is there, for which the final front view of the line is 50 mm and the top view is given, C point position is given, and one of its D point position is given with respect to the vertical plane. So let us see how to construct this particular problem. So first of all, as usually you will take a line X, Y and locate the point C, that is 50 mm in front of vertical plane and 15 mm above the horizontal plane. So first I will take 15 mm above the horizontal plane, that is C dash. This is already known. Okay, and next, this is 50 mm in front of vertical plane. So I will draw a straight line here and I will put a point C. So this is C, that is 50 mm. So you can write down the dimensions here. So this is 15 and this is 50. Is it clear? Now I know the positions of the first point of a line C and C dash, that is front view C dash is above the horizontal plane 15 mm and it is in front of vertical plane with 50 mm, right? And D point is 15 mm in front of vertical plane and it is above horizontal plane. So one position is given and another position is not given, and we have to find out the inclination and its front view also. So how to make that one? Then here one thing we have to do is D point location is given, that is in front of vertical plane. In front of vertical plane means that is nothing but the top view of the point D. So I don't know where it gets. So simply, first of all, I will take a point here, it is 15 mm above, and I will draw a light line. I think you may not see this one. Draw a light line passing through 15 mm. So here I will draw the dimension. This is 15. This is point D. Okay, this is point D. Now here I will write down this is locus of D, point D. I don't know where does the front view appears, because only the point D position in front of position is only given, but not above the horizontal plane. Here it is mentioned is above the horizontal plane. Where it is, I don't know, right? And you also don't know, right? We have to find out that particular position. So here what is given is CD measures 50 mm. So already the length of a line is given as 75 mm, right? And the CD measures means that is top view 50 mm. Where does the top view appears? So the top view appears below the axis. So now first of all, what should we do is we have to draw a parallel line here and draw a parallel line. Okay. Then first of all, what I should do is take a 50 mm line. Okay. So when this CD Okay, suppose if I take this parallel ray, let us take this is 75 mm. Okay, this is 75 mm. If I rotate this one here, this one is going to be, the top view is going to become as 50 mm. So now what I will do is, I'll take 50 mm from this particular point. Okay, take 50 mm here and draw a line from the 50 mm. Okay, so this is a very light line. Okay, then next, this is a line, that is because it is 50 mm, already it is given here. This is CD measures 50 mm. So from now, from C dash, I'll take the length of a line as 75 and simply I'll make a mark here. So now this is nothing but D dash and this is a line. Okay, when the line is inclined to the horizontal plane with some degrees with 75 as a radius, it becomes 50 in the top view. It becomes 50 in the top view. And where does the D dash is located? D is located 15 mm here. So simply by taking the length, the same 75, I locate this point and I draw it. So now I got this point D here. So this is the initial position of the lines. Initial position of the line. So then I can notice this is the 5 degrees. That is a vertical plane inclination. And simply this is to be rotated. Okay. This 50 is going to rotate onto this locus. Okay. And next, draw a line parallel to this one. That is locus of D dash. Write down this is locus of D dash. Okay. Where does the front view appears? This is the original CD line of 75 mm. Draw this one up to this point. So this is the, sorry, yeah. Sorry, this is the line. Okay. And this is a shorter distance. After coming, this is the shorter distance and this is the shorter distance. Simply what I do is, I'll take this length and I'll try to rotate. Sorry. Okay. I'll rotate this one to the point. Now I will locate D dash here and I locate this one D1 dash. Okay. Next thing. So here already I have a reduced length that is 50 mm. So here it is given the CD measures, the top view measures 50 mm. So where I have to locate it? So I have to locate this particular dimension to rotate on the locus of CD. Now this is D. So here I'll mark it as D and this is D1 dash. Sorry, not D1, D1. Now simply you draw a dark line from this point to this point and draw a line from this point to this point. So now this is the line inclined to both the planes. So now this one will become the apparent angle and this one will be the original inclination. So you can find out the original inclination with the horizontal plane as well as the original inclination with the vertical plane. So here this line length C and D is 75, already it is satisfied the conditions. C dash is above the horizontal plane and C is 50 mm in front of vertical plane. And here point D is located in front of vertical plane and here I got a locus line here such that I will notice how much above. So D dash, because here it is given as D is 15 mm in front of vertical plane and above the horizontal plane. So I can find out the height of this particular point D that is above the horizontal plane. So right, thank you.